Oracle database and instance architecture. In this nugget, we're going to take a look at what's really going on behind the scenes with your Oracle database. For example, we'll take a look at the actual database, and then we'll talk about, well, what's the instance and what's the difference between the two. You'll be surprised at how often people misuse these two terms. We'll take a look at all the memory structures required to run your Oracle database, as well as the background processes and how these slightly differ on Unix and Linux versus Windows. Similar to background processes, we'll take a look at server processes, which are essentially fetching information for us. And then we'll take a look at physical structures. What are the actual data files that are doing the work for us? We have about 7 or 8 different types of files that we'll be working with. We also have logical storage structures. Logical storage structures are those which can be queried through Oracle, but they cannot be seen on the physical operating system level. So we'll take a look at how all of your database objects are organized. For example, where are your tables going? Well, we'll talk about table spaces and what all is contained inside of a table space. And then the last thing we'll take a look at is we're just going to put it all together and talk about what happens when the database starts up. We'll also take a look at what happens when someone issues a query. And so you'll get the big picture of what's really going on. So let's get started. What's an instance and what's a database? Well, an instance is just a collection of background processes and memory structures used to tap into a database. And a database is just a collection of files that contain your data. Now in Oracle, these files are usually going to end in the .dbf extension. And these are binary files, so if you try to open it up in a text editor, good luck reading it. Unless, of course, you're really good at reading binary. I haven't met anyone really good at that yet. Really, the only way to access the data in the database is to issue a SQL query. Okay, so here on our upper diagram, we've got an Oracle instance. ORCL is, in our case, just the unique identifier of our instance. Now, your database has a unique identifier as well. That's the database name. And if you're in a situation where you've got one instance tapping into one database, most likely the instance and the database will have the same name. Now you can have a more complex scenario where you've got multiple instances tapping into one database. Here we have down here below. This is what we call a rack environment or real application clusters. And the whole purpose of this is to have 24/7 uptime. So if in case one of your instances goes down, the others can take over. So notice how our different instances have unique names. If you're ever curious what those values are on a database, you can simply type in at your SQL prompt, show parameter db_name. That shows you the name of the database. You can also say show parameter instance name, just like that. This show parameter command, that just shows us what our initialization parameters are set to, and we have a whole nugget covering all those parameters. So what exactly are these background processes and memory structures? Well, I've drawn you a nice little diagram to show you. Let's look at our memory structures first. Right in this inner rectangle, we've got the System Global Area, otherwise known as the SGA. The SGA consists of a lot of different components, but really the only required components are the 3 down here in red. We've got the buffer cache, the log buffer, and the shared pool. The other memory areas are all optional up here, the stuff in green. So focusing in on the buffer cache first, the buffer cache is just an area of memory that stores data blocks. Okay? Now, everything is stored in blocks in Oracle, and we'll discuss exactly what a block is in a couple minutes. But basically, if you issue a SQL query, and then you issue the same SQL query later, or a similar one that's accessing the same data blocks, instead of having to access that information from a file, it's actually grabbing it from cache. So it improves performance. When you make modifications to your data, that actually initially gets stored in the buffer cache, and then it eventually gets written to file. So you don't have this constant I/O activity going on. One of the biggest issues that we have with any database system is performance, and your goal is to have as little input-output or I/O activity as possible. Okay, so that's really the whole purpose of caches. Next, we have the log buffer. The log buffer is an area of memory that just saves changes made to the database, and eventually this will get written down to redo logs. The whole purpose of our redo logs is to perform recovery. Recovery is just the process of applying these redo logs to data files in case you had some corruption going on. So we'll talk more about recovery and how that works later. And then the shared pool is where parsed SQL statements get stored. So if you have SQL statements that are executed over and over again, they would get cached in that memory area, giving your applications better performance. The shared pool also stores data dictionary information. And well, what exactly is a data dictionary? Well, it's just a place where meta information about the database is stored. There's several hundreds of tables in the data dictionary describing what tables we have, what indexes we've got, what users we have, and so on. Let's hit on some of these optional memory areas. First of all, starting off with the Java pool, that's used obviously for Java. Oracle comes bundled with a Java runtime environment and some development tools. Then there's the streams pool. You're only going to use this if you're in a distributed database environment. In other words, if you've got multiple servers hosting a database. The large pool stores information about backup and restore activity as well as shared server information. Shared server simply means that we've got several clients sharing the same server process to grab information from the database. So we'll cover that in more detail in a little while. And the large pool also stores some other miscellaneous information, which we'll eventually get to. Let's talk about the keep pool. Now, things that you want to keep pegged in memory, such as lookup tables, are going to go there. And you can explicitly say, hey, I want this table to go in the keep pool. So it stays there as long as it can. Think of the recycle pool as being the opposite of the keep pool. If we need to do a full table scan, for example, we need to grab all the rows in a table, and we don't want it to clog up our main memory, our main buffer, then we can have this go to the recycle pool. And so if we happen to need this data, then it's there in the cache. However, it's not taking up space in our buffer cache. Before we talk about the 2K, 4K, 16K, and 32K buffers, I want to talk to you first of all about block size. Now in Oracle, you have a default block size for all of your objects. When Oracle is retrieving information or passing any information around, it's always going to be in block sizes. And when you install your database, you decide what your default block size is going to be. So here mine is 8K or 8192. Okay, 8 times 1024 is 8192. If I were in a data warehousing environment where I'm dealing with really large rows, I probably would have made my default block size be 32K. For everyday operations, 8K is good. Once you define the default block size of your database, it's set in stone. You really can't change it. But what's really neat is starting with Oracle 9i, Oracle has allowed us to have multiple block sizes. So in addition to our default block size, we can have up to 4 other block sizes. So looking back at our diagram, the reason why we're missing the 8K buffer is because that's already accounted for right here. That's the 8K buffer cache. So when you're creating database objects, you can specifically say, hey, I want this table to belong to the 32K buffer or the 2K buffer. And so if you've got a table that uses that block size, it's going to use one of that buffer instead of the default buffer cache here. Let's check out our processes. Anything in a circle in this diagram represents a process. Now down below here, we've got checkpoint, database writer, log writer, archiver, process monitor, and system monitor. So let's start off with our database right